As a member of the agricultural community, you know how essential your equipment is to your success. You also know the value of consistent maintenance for all of that equipment, especially your air blast sprayer. Part of that maintenance is regular calibration of your sprayer so that it operates in a safe and cost-effective manner. Improper calibration, or no calibration at all, can cause over-application or under-application of pesticide products. This can be costly in terms of impacting crop yields or unnecessary elevated application budgets. And that's what proper air blast sprayer calibration is all about. Accurate sprayer calibration lets you know that you are getting efficient use of fungicide, insecticide, fertilizer, stop drop, thinners, and other expensive materials that are going through your sprayer, protecting these investments in your equipment, the inputs you purchase, and the crops you grow. However, before calibration can take place, there are a few steps you will need to perform in order to make the process run effortlessly. If you haven't already done so, please review the video describing instructions for preparing your air blast sprayer before calibration begins. The calibration process itself is very direct, so let's take a look at those steps. Step 1 is determining the ground speed of your equipment. We do this by timing how long it takes for your tractor to travel at a predetermined distance and engine RPM level. This distance is then easily multiplied to account for total acreage. The tractor gear, RPM level, and pump pressure should be kept at the same level as you would run during a product application. For this calibration, the gear was BL3, the RPM level was 2200, and the pump pressure was set at 300. It's best to travel more than 200 feet in order to measure an accurate speed of the tractor and sprayer. This test run was a 264-foot course, and the time was 52 seconds. Run the course at least twice, once in each direction, to compile an average time. During this timing, you should be pulling your sprayer with approximately a half-tank load of water. In a field application, when a sprayer tank is full, your average speed will be slower. As it approaches empty, the speed increases. A half tank represents the average overall weight and drag during the course of an application. While in the field, be sure to measure the distance between the rows. Later, we'll use that measurement to calculate the application rate per acre. In this case, we measured 5 rows over 60 feet, or 12 feet between the rows. Return to a level area for calibration testing. Measure and record the nozzle tip size and the disc whirl plate size on each output. Step 2. Attach the calibration device to the sprayer. Secure these quick connect hoses onto all the nozzles of the sprayer being used in the application. Make sure the connections are secure, as leaks that occur during the collection process can provide false results and compromise the accuracy of the calibration. Also, verify the order of the collection hoses to make sure that each collection tube corresponds to the appropriate nozzle. If you do not have access to equipment specifically designed for calibration, a little ingenuity can provide alternate methods of collecting liquid output. Step 3. Bring the engine up to the previously determined RPM level and sprayer output pressure set for field application. Make sure that the collection tubes are not engaged while waiting to reach RPM and pressure levels. Step 4. Collect sprayer output for a period of time, say 15, 20, or 30 seconds, that can later be multiplied to an equivalent of 1 minute. The closer to a full 1 minute collection time, the more accurate the results will be. This figure will be used later when determining the amount of product sprayed per acre. Step 5. Record the output for each nozzle in the appropriate section of the calculation form. Step 6. Calculate the total output in gallons per minute. This is done by adding the totals recorded from each nozzle and multiplying that total by the appropriate figure to determine the per minute output. If you choose to only collect from one side at a time, repeat steps 2 through 6 for the other side of the sprayer before determining the per minute output of the nozzles in total. Then, using the measurements from step 1, determine the total amount of gallons per acre applied. After the total GPA figure is calculated, it may require making adjustments in order to accomplish your application goals. This could include changes to your application speed or sprayer pressure output. Or it could be that adjustments are necessary to your nozzles and/or disc or whirl plates. You may need to check filters, screens, or other parts of sprayer equipment. It can also lead to the discovery of incorrect nozzles or disc whirl plates having been installed. Often, these equipment changes can be determined during the collection process, as visible differences in expected output and actual collection may be obvious. Remember, if you change the pump pressure or the nozzle type, nozzle size, or whirl plate, you will need to repeat the calibration process to determine an accurate gallons per acre rate. It's important to recheck sprayer calibration throughout the growing season. So many elements of agriculture work can be inconsistent, especially in relation to the weather. However, you can always count on proper sprayer calibration to provide you with safe and cost-effective equipment each and every year. Thanks for watching.